In this video we're going to have a look at identical portions of a curve. So quite frequently in ellipse and parabola questions in particular, once you have the main curve worked out, maybe you were given a major and minor, maybe you were given a major and a point in the curve, or a minor and a point in the curve, focal points, whatever it happens to be. Once you've solved the initial part of the question, at a later stage it often reads something like any one of my three scenarios here, or there are plenty of other variations, but I've three set up and I'm going to work through them here. So the first one I've set up there is, let's just say you've gone ahead, you've drawn this much of the question, and there's a portion of an ellipse here from A. So the question might read something like that: draw a portion of the same ellipse with A as the vertex, and it has to hit the existing ellipse. So A down to B. So A is the vertex. So the vertex in this ellipse, the main ellipse I just drew, is I've just labelled this M, N, O, and P. So M and O are the vertices of this main ellipse we already have. So they want us to change, take a portion of the same ellipse and draw it from A down to hit. So we don't know what height it is, we don't know what width, we don't have anything else except that A is now the vertex, and they want something similar shape to what we already have right here, and down until it hits there. We'll just call it point B. Now, some people might be thinking of majors and minors and constructing a new ellipse. That is not the way to go. It is absolutely unnecessary. Okay, so we have a much better way of doing it. What I'm going to do is this: I'm just going to start drawing without too much explanation here. We'll just start drawing into this. I'm going to keep with my colour scheme. I'll just go over a slightly lighter green so that it's not too dominant on the sheet. And I'm just going to take, what I want here is I'm going to take this portion, so M working down this way. I want to take that curve and I want to move it up here. Okay, so I want to basically copy that curve right there and just drop it up here instead. So take a portion of the same curve and move it up. What I'll start off with is this: I'll just plot out some points. So I'm going to go, I have no idea how big this is going to need to be. I'll just go 10, 20, 30, 40, 50. So I've worked down from my vertex, down 10, 20, 30, 40, 50, and I'm going to do the same down from my vertex again. Now I'll just extend down that line a little bit. And you know what? I'm going to go with 60. And that might be enough points, and it might not be enough points. I'll find out. So, working down from the vertex, which was at M, at this portion, and vertex will now be at A. I've gone 10, 20, 30, 40, 50, and 60, and I'm going to do the same here. So, 60. So, what's next? Next thing is I want to bring in my T-square here, and at my 10mm mark, which is, I just call that point 1, 2, 3, 4, 5, and 6. So I have 6 steps down along the main axis. At my 10mm mark, that is the distance out to the curve. 20, 30, and so on. And there we are. I have just mapped out some points that are on the curve. So I've gone down 10 and I've gone out whatever distance that happens to be. I've gone down 20 and I've gone out again, whatever that is. 30, 40, 50, and 60. So at each increment that we went down 10mm from the vertex, we went out perpendicular to the axis, of course, perpendicular every time, until we got a point on the curve. Let's apply the same rule. We went down our 10, 20, 30 and number them as we go down along. So 1, 2, 3, 4, 5, and 6. And at every point I want to go perpendicular to the axis. And along every one of those lines I need to just set the same distance. So from point 1, when I went down 10mm, the distance out to my curve was right there. So get this accurately if I can. So with the distance out, I'll set that distance out. And that gives me a point on the curve. 1.2, that's the distance out. So I'm moving down to 2, there's the distance out, and so on. You know where this is going now? 2. What do I find? I find that I haven't actually reached the curve yet, so what I do have is this range of points now: 6, 5, 4, 3, 2, 1, and vertex that I can freehand in, but I haven't reached the curves yet, so I need to add in some more. I'm after making a very big question of this one now. I'm just going to go 70 at 0.7. I'll take my distance out to the curve. There's 7. It's again, it's perpendicular to the axis right there. I need to take the corresponding 7. And a distance out to the curve. And this time we have it. So that gave me 0.1, 2, 3, 4, 5, 6, 7 right there. All points on the curve. And I'm going as far as 7. And then I heavy in what needs to be heavy. So we go right up to the vertex there, the new vertex of A. And then we heavy in until we reach point B on the curve. Now, that is it. That's the first one. So I've just used my compass. The compass is the main one here. I've taken a certain number of increments going down along the major axis right here, working down from the vertex. I've gone off at 90 degrees to each one, and I've taken a set distance out to the points. So I've taken the same increments down along the major. I've gone down to each one. I've gone off at 90 degrees, of course. For every single one of them, off at 90 degrees. And I just took, the main thing here is take one too many points, okay? So to get to the curve is here. Well, I need that next point. I need to point my curve at the end towards a point nice and lightly, and then I'll know exactly what to heavy in. And there we have that particular scenario solved. So if this is kind of the hardest one of the 3 that I'm going for now. If it's from a fixed point and it has to hit the curve, then we just take a random number of points. If like me, I took 6 and it wasn't enough, so I had to go back and take number 7 again. If you need more points, add in more points. So it's all about the ratio of distance down to distance out, distance down to distance out. There's scenario 1. Scenario 2 is once the elliptical object is drawn here, and if we wanted to put a base, a 40mm high stand based on the same curve with the vertex now at point P. So from point P I went down 40, so that's going to be the floor now, that's going to be the ground, and I want a stand that goes up, hits P, comes back down, and it has to be 40mm total height. So what do I do there? I'm going to do, well, what I've already done is I measured down my 40 and I drew my ground lines. That's now the base for this object, and I need my 40mm high stand, and the vertex will be at P. So 40mm off a vertex. Oh, measure back in my 40 right there, and again I'll keep orange here just so that we have it all color coded. That right there. I need to take, so that's a 40mm height. I need to take whatever portion of the ellipse here gets captured by this 40mm height. So from this point right here up to the vertex and back down to this point right here. I need all of those. I need all of that curve right there and I need to bring it down and push it here. So it's going to be the same process again. Now I'm not going to draw the full lines across every time. I'm going to just step out now a few different increments again. Now it's 40, so the easy one is 10, 20 and 30. At each one we'll step perpendicular to the axis to hit the curve. That is from the apex down to 1, 2, 3 and 4, 10, 20, 30 and 40. From the vertex again down to 1, 2, 3 and 4. And we step off perpendicular to the axis. But of course this time it has to be left and right. Next, when we go down to point 1, we take our width. So it's the same thing again, and that would be the width same on the other side if I had brought one up and down, but it's the width at point 1, left and right. Same for 2, same for 3 and same for 4. And there we have it. We end up getting base point, point 3, 2, 1, then we have a vertex, and then 1, 2, 3, and a base point again. Sometimes because these guys get so they shoot in so quickly towards that vertex, sometimes it's nice to just drop an extra point in there so that we have something else to structure the freehand curve. But it's not necessary, but I think for some people that aren't as comfortable with freehanding, they prefer to have it there. But that's enough really. We've loads of work done at that for this portion. So that's a portion of an ellipse of a given height. Once you've freehanded in nice and light, go over it if you're happy. And there we are. Ellipse, that's in this case an elliptical stand of a given height. The final scenario here I have set up is number 3 there in pink. A 35mm wide portion of the same ellipse with the vertex now at point O. So it's going to come out just like that. 35mm wide, and it'll stop someplace because I've just measured out 35. I've drawn my vertical line, so the vertex is at point O. And at 35mm wide, I need a portion of the ellipse, and wherever it stops there. So we've already had from a starting point to hit an end point, a limit. We've had a specific height, and now we have a specific width. So let's go and do that much. First off, I'm going to measure from the center. I might just use the center because I have a line. I'm going to measure down 35, right there. I'm going to take that, bring it over to hit the curve. Now I know that from the vertex down to here, that is the portion of the curve I need to move, to copy and move over here. So that's it. It's going to be repetition of the same thing now. I don't have that much stuff. So this is the portion of the curve now that I need to move over, right there. And it is that portion because I've taken the only constraint I was given, a full 35mm wide, and I've set 35mm wide. Next, I'm going to, what should I use here? Do you know, I can do this any way I want. I'm not going to use too many increments here. It's it's about, let's just call it about 27, so I'll go 9, 18, right there, 9, 18, 27, and I'm not exactly certain of what measurements I marked there, so just to show you another way to map this out and maybe even more accurate. Okay, so on pink number 1, pink number 2, and pink number 3, they're the points I'm working with this time, and they are the references I'm working with. So how do I map those out? I'm going to use nothing but my compass this time. So first of all the way down to number 3, so for a 35mm wide portion, we'll go down to here. That's the end of the object. Let's draw in, I'm going to just draw in that rectangle that it'll fit into. So from the apex, or the vertex I should say, down. Yeah. That's number 3 right down there at the end. Along the way to 3, we catch number 2 right there. 0. Down to 2. And we have 0. Down to 1. So there is 1, 2, 3. Stepping off perpendicular to the axis, just like each other example. Out of 1, out of 2, and of course, as we already have, out of 3. And take our corresponding widths. The width at 1 is here. Width at 1. The width at 2. Is the width at 2, and just to make sure we get this right, the width at number 3 should be 35, width at 3 there, 35. So we get points 1, 2, and 3, portion of the same ellipse. And there we are. In each case, we are just looking for proportionate distances down along the axis, out to the point, down along the axis, out to the point. Same here when our constraint was 40mm high. We went down along the axis, out to a point, and mapped out the same down the axis, out to a point. And finally, of course, once again, down along the axis, out to the point. But each time we were given different constraints. We just had a start and an unknown finish. We just knew it had to hit the curve. We had a specific height and we had a specific width. So there we are. That is the 3 worked examples. Big question is, can you be asked in any other way? And yes, of course you can. You could also be asked to base it on your parabola. So could you be asked to base it on a specific start and finish? Yes, you could. So you might just be given a start point right here, told that that point A right there is the new vertex, and what you would need to do is find a portion of the same curve from A. Now, just to go through the last method that might also work here, if you're dealing with, and you'll know from looking at the question, if the axis is vertical in one view, and you know from looking at the question, on your identical ellipse that you need to draw over here, the axis is also vertical. Okay, so if you know that the main axis of the ellipse is vertical and it's also vertical in the identical, parabola, the identical parabola also has a vertical axis. So if the main axis is parallel to the identical portion axis that you're looking for, then you can do this. You can actually make this a little bit easier. I think it's a little bit easier this way, but only if the axis of the original and the new are parallel. You can do a translation. Translating a range of points. So I'll just work with the ones in blue there that I've already worked with before. Translate a range of points down along. I don't know how many to take again because I'm not sure when it finishes, because in this case this type of question might be finishing on the curve again. And the translation has our direction and our distance. Distance from V down to the new vertex A, stepped off an every point. So you can translate a curve only if the original axis and the new axis are parallel. And there we are. So that is a translation to solve this question. That's the really important point right there. Only if the axes are parallel, the axis of the original object being parallel to the axis of the new object, and that will work as well right here, same thing. So if the portion of the ellipse was for a parallel axis, you could use your translation over here. In each case though, we were taking it from one position and we were standing it up or taking it and sitting it down, so the axis was changing from one angle to another. So that's not going to work, but just the last way that you could answer the question is right there. Also, the three scenarios I set up here can also apply here, where you are given a specific height of, let's say, 35 mil right there, and you have to get that portion of a parabola and draw it elsewhere, or draw it maybe facing sideways, or a specific width where you might set out your width, bring it down, hit the curve, and then you know that that's the portion. That is just a quick video showing identical portions of a curve in the context of Junior Cert ellipse and parabola questions. Thanks very much for watching, and I hope it was helpful.